Hello, everybody. This is Gigi from Kauai Community College. In this video, we will be talking about the first case out of four scenario of partial fraction decomposition, which means to break the fraction into smaller parts. Okay, and let's take a look. Suppose you have x plus 12 over x squared minus 5x plus 6. Well, if you think about this here, the denominator can be factored out to be x minus 2, x minus 3. So this fraction here must have come from two smaller fractions if we were to split them up or decompose this fraction. So it must have come from something over x minus 2 plus something else, or maybe the same thing, we don't know, over x minus 3, right? The question is, what are those question marks? All right, now let's call that A and let's call this B. And then what we're going to do now is we're going to say, well, let's actually go perform that addition to see what the answer would be in terms of A and B. Okay, and to add two fractions, I would need a common denominator. So I would have to multiply the first fraction by 1, and that 1 is x minus 3 over x minus 3. And then I'm going to multiply the second fraction by 1 also to get an equivalent fraction. And that 1 is x minus 2 over x minus 2. Now that they have a common denominator, I can write that common denominator and add the numerators. So here I distribute out the ax minus 3a, that's that, and then bx minus 2, right? So that gives us the same fraction as the one that we started out with, except for now it is in terms of A and B. Yeah, so since the denominators, these right here, are the same, the numerators will have to be the same, right? They would have to be the same because the denominators are the same and they are supposed to be equal, right? So now what I'm going to do is I'm going to go ahead and match the coefficients. What does that mean? How many x's are there on the left-hand side? 1. How many x's are there on the right-hand side? A plus B. And the constant on the left-hand side is 12. What's the constant on the right-hand side? Negative 3a minus 2b, right? Therefore, this right here got to be 1 because that matches with that coefficient. This right here got to be 12. So what we have is a system of equations. A plus b equals 1, negative 3a minus 2b equals 12. And I'm going to solve this system of equations by elimination method by multiplying both sides of the first equation by 2. And I'm going to add those together to eliminate b. So negative a was equal to 14, so a is negative 14. Now that I know a is 14, I'm going to go back to the first equation and substitute a being 14, negative 14. So I have negative 14 plus b is 1, therefore b is 15. So we have found those question marks that we were looking from the beginning. The first one is negative 14 and the second one is 15. Therefore, the fraction that we started out with can be decomposed into negative 14 over x minus 2 plus 15 over x minus 3. Okay, now just to check, okay, if I was to go ahead and perform the actual addition problem here, I'm going to multiply this by x minus 3, x minus 3. I'm going to multiply this by x minus 2 and the denominator by x minus 2 as well. What am I going to get? Negative 14x, negative 14x plus 42 over x squared minus 5x plus 6 plus x squared minus 5x plus 6. And on the numerator here, I have 15x minus 30. And if I was to keep the denominator the same, that's the common denominator, and add the numerators. Negative 14 plus 15x is x. 42 minus 30 is 12. I have what I started. So as we can see, the fraction here is x plus 12 over x squared minus 5x plus 6 can be split into negative 14 over x plus 15 over x minus 3. And that is how we decompose a fraction. So to summarize what we have seen, that would be case number 1 out of 4 is if the denominator are non-repeated linear factors. Okay, meaning it's equals to x minus a, x minus b, x minus c, and so on. Then the fraction can be decomposed to a over x minus a, b over x minus b, c over x minus c, and so on, where a, b, c are constants that we need to be determine, right? For example, let's take a look at the second one, just so we can digest this information. Suppose you have 3x over x squared minus 2x minus 8. The denominator will factor out to be x minus 4x plus 2. So these are what we call non-repeated linear factors. Therefore, we can decompose that into a over x minus 4 plus b over x plus 2. Okay, I'm going to let you ponder for a second why it couldn't be linear up here, meaning why couldn't it be ax plus some c? Okay, suppose that's the case, then when you get a common denominator, what do you have to multiply by? X plus 2 over x plus 2. Guess what happened when you multiply and distribute in? You're going to get ax squared, which is not what you started out with, right? So it has to be a constant. Now, or another way of thinking about it is this right here really is a proper fraction, right? So the degree on the numerator is going to be smaller than the degree on the denominator. Okay. All right. So anyhow, suppose we were getting that common denominator and we are going to multiply this by x plus 2, right? And then we're going to multiply the x plus 2 over x plus 2 and the other one by x minus 4 over x minus 4. And suppose we distribute out the a, we will have ax plus 2a. And then we have bx minus 4b. Okay. When we match the, when we factor out the x term, we have a plus b, and then the constant is just what it is. Now, if we were to match that to our original fraction, then your a plus b got to be 3. And then my constant 2a minus 4b. What would that be? Well, 3x is 3x plus 0. Therefore, 2a minus 4b got to be 0. So we have the system of equations, a plus b equals 3, and 2a minus 4b equal to 0. I'm going to go ahead and multiply both sides here by -2. And then I'm going to go ahead and add the two equations together to eliminate a. I have -6b equals -6. Therefore, b equals 1. Now that I know b is 1, I'm going to go back to my original equation, substitute in 1, and a is 2. Therefore, our fraction is going to be decomposed to 2 over x minus 4 plus 1 over x plus 2. And that is how we decompose fractions with non-repeated linear factors. Okay, keep watching the next 3 videos in the series to complete the lesson.